Welcome to the first lesson of the Zig Language Basics course. In this lesson, we will learn about the Zig language, its history, the reasons for its development, and how to install it on your device. What is Zig language? Zig is a relatively new programming language developed to provide high performance and flexibility in writing code. Zig was designed to improve some of the shortcomings found in other programming languages like C and C++. Zig aims to offer optimizing performance and reducing execution time, minimizing errors related to memory management, providing a straightforward and clear syntax, making code easy to transfer between different systems. Zig's development began in 2015 by Andrew Kelly, with the first version released in 2016. Since then, the language has grown in popularity due to its features and flexibility, and it has been used in a variety of applications. To understand the importance of Zig, we can compare it with other popular programming languages like C and Rust. Zig offers similar performance to C. Zig provides better safety features like bounds checking and more secure memory management. Zig has a simpler and clearer syntax compared to C. Both languages offer high performance. Rust is known for its strong safety features, but Zig also provides good memory safety. Zig is simpler to learn and use compared to Rust. To install Zig, follow these steps. Visit the official website at ziglang.org. Click on the Download button. Then, click on Install Zig from a package manager. Scroll down until you find the section for your operating system. In my case, I am using Windows, so I will copy the provided command for the Windows. Open the command line interface for your operating system, paste the copied command, and wait for the installation to complete. To ensure everything is working correctly, close the current command line interface and open a new one. Type the command Zig version. If the Zig version number appears, it may vary if you are watching this video in the future. It means Zig has been successfully installed and is working on your operating system. This way you have installed Zig and verified its operation. To start writing code, we can use a plain text editor, but I would rather die than do that. Instead, we use what is called an Integrated Development Environment, IDE. An IDE is similar to a regular text editor, but is designed to be a comprehensive work environment that offers more features and conveniences for programmers. This helps increase productivity and reduce the time spent writing and testing code. There are many code editors available, but I prefer using Visual Studio Code. It is simple, easy to use, and understand. You can install it by visiting the official website at code.visualstudio.com, then clicking on the Download button. After downloading, open the file you downloaded and complete the installation process. Once installed, open the application, click on the extensions icon, type Zig, and select this extension, then click on Install. This will set up a ready-to-use environment for writing our code. Now let's start creating our first project in Zig and writing our first program. Firstly, create a folder to containing the Zig project. Secondly, open this folder using your code editor. Third, create a new file with any name you want. In my case, I will choose the name main, but the file name must end with the .zig, which is the extension of Zig files. Now we have a project that consists of a folder containing the files for this project, and we have a main file called main.zig to contain the main code of the program. Now let's start writing the code that will make up our program. But before that, we must first think about the purpose of this program in order to write it. In my case, I want to give a very simple example of Zig language. So we can start with something very simple, like print the hello world sentence. But before start writing the code, it must be pointed out that it is not necessary for you to understand everything now. This is just a simple example, and I will explain everything in boring detail in later lessons, so do not worry about what you will see now. To print something in Zig language, you must use what is called the standard library std. In all programming languages, there are libraries that can be used to provide additional functions. Whether these libraries are original libraries included with the language itself, and this is called built-in, or external libraries that were produced by other people or companies, and this is called third-party libraries. To use a library, we must first import it. So we will use the import keyword and add the @ sign before it. I hear a voice from afar asking me, why do we add the @ sign? Well, every programming language has something called syntax, which means the way the code is structured or those sentences and words that we use to write codes in general. Syntax refers to several linguistic rules that must be used to determine the purpose of a written word, which can be thought of as the grammatical rules of the language. Therefore, these rules simply must be memorized so that we can talk to the machine in a language such as Zig. I hope that this explanation is sufficient for you to understand what syntax is. Now let us return to our topic. As I said, to import a library, we use the keyword import with the @ sign to tell the machine that we want to import a library. After that, we must specify the library to be imported, and we do this by opening parentheses containing double quotation marks containing the name of the library to be imported, which in our case is std library. However, importing the library alone is not sufficient. For example, think of a library in your city. Can you access it without a clear address? Certainly not. Therefore, we need to reference the library we want to import using an address or a name, which is known in the programming world as constants. To create a constant, we use the keyword const, which is short for constant. After that, we write the desired name. For example, we will write std. Next, we add an equal sign after the name. At the end of the line, we add a semicolon to inform the compiler that we have finished this line and that anything following it is separate from this. All right, I can hear the same voice asking, what is a compiler? Well, imagine we have a script like this. What we see here is just a script, or in other words, just text, and not an actual executable program. To convert this script into an executable program, we need to transform the symbols written in a language like Zig into machine language, which consists of zeros and ones that the computer or machine can understand. Of course, we won't manually convert it to machine language because that would be absurd and a waste of time. This is why the compiler was invented. It reads the script, ensures it is free from any potential errors, and then converts it into machine language, returning it to us as an executable file, like any other program. I won't delve deeper into this, but in general, the compiler takes the human-readable code and translates it into machine language, enabling the machine to understand and execute the instructions. Now, let's get back to our topic. We define a constant named std and set it to import the std library, then ending the line with a semicolon. I hope things are clear enough for you, and even if they aren't, don't worry. We haven't really started the course yet. We are still in the first lesson, which can be considered a simple introduction. So, we have imported the library, but how do we use it? Well, before we learn how to use the libraries we've imported, we first need to understand how programs work in the first place. In Zig, a program may consist of multiple files and libraries, but there always needs to be a main file containing the application's entry point. So what is the entry point, and how do we create it? The entry point is a function called main. I hear the same person from earlier asking, what is a function? Can someone please silence this person? I'm tired of explaining everything in detail. Anyway, there are three main things you need to know about: constants, variables, and functions. Let's go through some examples to understand them more clearly. Imagine we have an application that performs a simple calculation to produce a result based on user input. For example, the program will add any number the user provides to the number 1 and then display the final result. In this case, the first field contains the number 1, which the user cannot change, and this is called a constant. The second field allows the user to enter any number they want, and this is called a variable. The third field displays the result, which is the sum of the first and second fields. This field is different from the previous ones. In the first field, we have already set the value to 1. In the second field, we expect the user to enter any number they want. But in the third field, we don't have a predefined number to display, and we don't know in advance what number the user will enter. So this field needs to be smart enough to perform the addition of the previous fields and display the result to the user. And this is called a function. Now, if we want to write these fields using the Zig language, we will define the constant using the keyword const, then write the name and specify its value. For the variable, we will define it using the keyword var, then write the name and specify its value. For the function, we use the keyword fn, short for function, then write the function name followed by parentheses. After the parentheses, we write void. And finally, we open curly braces to contain the logic of this function. The void keyword indicates that this function will not return anything. For example, in the previous example, the function should return a number, which is the sum of the two fields. So we would specify the return type here to number. Don't worry about types for now. I will explain them in future lessons. Just understand it this way for now. Another important concept to understand is scope. In Zig, this main function is called from another function called start in another file. However, for privacy and security, no other file can access the contents of this file. To make this function visible for other files, which we consider the entry point of our application, we define it as a public function by adding the keyword pub, short for public, before the function declaration like this. I know it sounds confusing, but trust me, there is a reason for everything. Once we understand the reasons, it will become clear. Don't hesitate to replay the video and listen to the part you didn't understand as many times as needed. As I mentioned, everything will be explained again in detail in future lessons, so don't worry. This is just an introduction. Now let's get back to our topic. We have defined a constant named std that imports the standard library in the first line. Next, we have a public function called main. As you may remember, our goal is to print the message "Hello World" using the standard library. So how do we use the standard library to print this message? Simply, the library may contain sections, and sections may contain subfunctions that perform specific tasks. In our case, we write std inside the main function to indicate that we want to use that library. Then we need to access a section in that library called debug. So we write a dot followed by debug. Now, we want to use a function that prints the message we want. Thus, we use the print function. As we did before, we use a dot to tell the compiler that we want to access a function within the debug section, which in turn is within the std library. To use the print function, we open parentheses, and inside the parentheses, we write double quotes to enclose the message we want to print. For example, I will write "Hello World" and then add the /n symbol to indicate printing an additional blank line after the desired text. After that, I add a comma, followed by a dot and open curly braces. At the end of the line, I add a semicolon to end this line. Now the same person asked me, why did we add a comma? What is the purpose of the dot and curly braces we added? Simply, the functions take what are called parameters. For instance, if I were thinking of creating a function that sums two numbers, I would define a public function like this and write the function name as sum_of_2. I would then open parentheses, and inside the parentheses, I would add two parameters. The first I will name a, and the second b, and I will give each parameter an integer type. A quick note, to specify the type as an integer rather than a decimal, we use the integer type, which is written in Zzzz as I32. We precede it with a colon to indicate that the parameter type is an integer. An additional note, don't worry about data types right now, as that's not the goal of this lesson. Just understand the concept and purpose of this explanation. I will explain everything in detail in the upcoming lessons. Now let's go back to the example. I will also set the return type of the function to integer. Inside this function, I will write the necessary logic. For example, if I want to sum the numbers a and b, I will write a plus b and precede it with the word return to inform the compiler that this function should return the value resulting from this summation. And of course, we will add a semicolon at the end of the line. Now, if I want to use this function, I will write the function name sum_of_2, then open parentheses and pass the numbers to be summed as parameters. For example, to pass the value for parameter a, I will write 10, followed by a comma, and then write 5 as the value for parameter b. Now, we must ask ourselves an important question. Where will the return value of this function be stored? Note that if the function's return type is void, there is no result to store. However, if the return type is anything other than void, we need to store it in either a variable or a constant. In my case, I will use a constant named result and end the line with a semicolon. If you understand this example, you will understand that the print function in the debug section of the standard library takes two parameters. The first is the text to be printed, and the second is the additional data, if present. For instance, instead of printing "Hello World" like this, I will delete the word "world" and replace it with curly braces containing the letter S, which indicates a string type. Here, between these braces, I will add the string to be inserted. For example, I will write "world." Similarly, I can delete the word "hello" and add curly braces containing the letter S to indicate that a string should be inserted in this place from the sent data. And in the sent data, I will add the string. For example, I will write "hello." Note that the first string will be inserted here in the first position, and the second string will be inserted in the second position, and so on. I hope you have at least a basic understanding of why we initially added these braces and did not just rely on the text alone as in this example. If there are parameters in the function without values, it means we need to send values, even if they are empty, to those parameter places when calling the function. I hope I have managed to explain things on a basic level. And for the 1000th time, don't worry if you don't understand. I am here to provide a quick overview, so you won't be completely in the dark. Trust me, this quick and seemingly complicated information will make things easier in the upcoming lessons, because you will have a background about the language and some important details. So, when you watch the next lessons, things will be clearer for you. Don't worry. Now we have this file that contains code to print the "Hello World" message. How do we run this code? Simply, we open the command prompt by clicking on the terminal menu and selecting New Terminal. Then we write the command zig run main.zig. This command consists of 3 parts. The first is the word zig, which we use to call the zig application, which contains the zig compiler. Next, we have the word run, which we use to tell the zig application that we want to run some code. Finally, we have the name of the file that contains the code to be executed. After that, we press enter and wait for the application to return the result like this. All right, before we move on to the building stage, we should take a look at errors, which you will encounter sooner or later as a beginner. There are several types of errors, some of which can be detected at runtime. For example, if you remove the semicolon from the end of this line, you'll notice a red underline and the file name at the top turning red, indicating an error in this file. You'll also see the error count next to the file name. For instance, if you remove the closing brace of the main function, you'll notice a red underline where the removal occurred, and the error count next to the file name increases. You can also look at the Problems tab, where the number of errors is displayed next to it. Now, to identify and fix errors, you can click on the Problems tab, and you'll see 2 errors listed. The first one indicates that the expected semicolon at the end of line 5 is missing. Simply click on the error you want to fix, and the code editor will move the cursor to the error's location in the file. Then, add the missing semicolon, and the error will be resolved. The second error tells us that an end-of-file error was found. EOF, which means the file does not end as expected. This happened because we removed the closing brace of the function. Similarly, click on the error, navigate to the location, and add the closing brace to properly terminate the function. Now, as you can see, the file name turns white, and the errors are resolved. There's also another type of error that occurs during code compilation by the compiler. For instance, if we remove the public keyword from the main function and try to run the file using the command zig run main.zig, we will encounter a seemingly intimidating error. However, try to stay calm and understand the error to know how to resolve it. If we read the provided information, we will see it tells us that the main function is not marked as a public function. To locate the error, you'll see it says declared here, meaning the error is located in this file and line. To jump to the error's location, press Ctrl and click on the file path displayed, and it will take you directly to the error's location in the specified file. But to understand why this error occurred, if you press Ctrl and click on the file path that triggered this error, it will take you to a file we haven't seen before. If you recall the explanation about the scope a little while ago, you'll remember that I mentioned to run the program using zig. The language itself will call our entry point, which is the main function in the main.zig file. When this file tries to call our function, it finds that it is a private function limited to the scope of its file, hence it cannot access it. It may seem strange at first, but as I mentioned earlier, if we understand the reasons, everything becomes logical and clear. So don't worry. Now, let's get back on track and resolve this issue by adding the public keyword to our function. If we try running the code again, we will see that it works without any errors. This was just a quick overview of the errors you might encounter and how to resolve them. Now, if we assume that we have finished writing the entire code and want to create a standalone application file that can be run by double-clicking it like any other application, what do we do? Simply, this process is called building. To build the application, open the command prompt again and type the command zig build exe main.zig. The term build exe means to build an executable file. Now, press enter and wait for the application to finish. Now, after the build process is complete, we will end up with 3 files. The first one is the application itself, which is in the exe format, meaning it is an executable file like any other application. Please note that the exe format is specific to Windows applications, and the file format may differ from one operating system to another. Next, we have 2 other files, one in the object format and the other in the program database format. I won't explain their purpose right now as it requires knowledge of concepts we haven't covered yet. But in short, these are auxiliary files generated for linking and debugging purposes. You can ignore them for now. I will delete them now to avoid confusion. Now, we can focus on our executable file. Right-click and select Reveal in File Explorer to open the file location. Now we can open the file by double-clicking on it. However, as you can see, the program opens a black window for less than a second and then disappears. Did we do something wrong that caused this issue? Well, this isn't a problem, but rather normal behavior. In fact, the program opens a window, performs its task, which is to print Hello World in the window, and then closes because it has finished its job. There is an additional way to run such programs, running them in the command line interface. For example, we can return to the code editor, go to the terminal, and type /+/ file name. The terminal will run the application and display what the program outputs here in the command line interface. In conclusion, we have covered the history and reasons behind the development of the Zig programming language, compared it with other languages like C and Rust, set up our development environment, and written our first Hello World program in Zig. We also explored how to handle errors and how to build an executable file from our code. I want to let you know that creating this video took a lot of effort and more than 10 days to produce due to my limited time. Originally, this course was intended to be a paid course on Udemy, but I decided to share it for free with everyone. So, if you found this video helpful, please let me know in the comments and consider subscribing to the channel. Also, let me know if the video was good or if it needs improvements in terms of audio, editing, or any other aspect. Remember, this video is just an introduction. I will explain everything again in more detail in dedicated videos for each topic. If I see good engagement, I will speed up the production process and aim to release 1 or 2 videos each week. Thank you for watching, and don't forget to subscribe and hit the notification bell to stay updated with all the new content. See you in the next lesson.